this area right in here represent?
The toe, like grays.
Base plus fog. It's even below the toe, exactly. Base plus fog, so what does that tell you? What am I talking about, base plus fog?
I'm supposed to.
It's the natural, inherent
Okay, let's combine what you guys just said,
background.
because you guys are all right. It's going to be the density that is simply from the base, which is your blue dye that's in the film, and any fog that the film has received, or any background radiation, background exposure that it's received. So it would essentially be the amount of density after only processing takes place. So if you took a piece of film out of the bin, put it through the processor, measured it with the densitometer, that's what your base plus fog is going to be. Now we know that the base plus fog should be between what two numbers?
0.0.
0.1 to 0.22, exactly. 0.1 to 0.22. If it's above 0.22, what is that going to indicate, or?
That you need to get rid of it because
Okay. It could mean that your processor is off, yeah, they would do further sensitometry testing for that. But more than likely, it means that your film has been exposed to a little more background radiation than it should have, which means it's more sensitive and it's probably not going to be useful. Okay. This little part here, we'll say that this is 0.25 and this is 2.5. What did we say that little area there would be called? The toe. Okay. What does that represent?
Very light grays that are not diagnostic.
Okay, very subtle tones, non-diagnostic areas of gray. Good, and then when we talk about processing a little bit later on today, we'll talk more about this. It's the result of phenidone interacting with your film. We'll talk more about that a little later. All right, so the most important part we said is this here, correct? And that just is referred to as what? Straight line portion, okay? And we know the entire straight line portion is going to fall between 0.25 and 2.5 because why?
it's the diagnostic range.
Okay, that's our diagnostic range. Okay. That's the range where we can actually see a shift in densities. Now, we also not only gave you those numbers yesterday, but we talked about a couple of other numbers where most of your diagnostic information should fall between. Okay, so those 0.5 to 1.25. 0.5 to 1.25 is where most of your diagnostic information should be. So most of your diagnostic information is probably going to be in about this area. Okay, above that, this little area there, what do we call that? Shoulder. That's obviously, if this is the diagnostic range, that's out of the diagnostic range. Darker than what can be distinguished with the naked eye. Hydroquinine is the chemical that's going to produce those very, very dark tones. And then above that, this area here where it kind of tapers off, what's that called? The Dmax. What's that all about?
Maximum exposure for the film before it starts to actually light.
Okay. It's the absolute, that's when all the black metallic silver that's incorporated in the film has been exposed and processed. That's your Dmax. Can't get any darker than that point. Now, Todd was just getting into this. If a film is constructed to its Dmax, what's going to happen if you take an X-ray with that film? Okay, everything that looked black is going to look white. Everything that looked white is going to look black. Because we started discussing yesterday, and we'll talk more about that now, talk more about that today. We said yesterday, when you normally take an X-ray with just normal film, those electrons are going to gather at the sensitivity spec, and that's going to attract a positive silver ion, and they're going to gather at the sensitivity spec. Well, if it's exposed to the D-max, all the silver ions are essentially already at the sensitivity spec. When you expose it again, they're gonna be repelled from the sensitivity spec. You process it, all your blacks are gonna look white, all your whites are gonna look black, which is called reversal or solarization. Okay,